Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. Plain and simple, organizations face risks that have varying levels of impact to the organization, and that risk has to be handled somehow. Risk management is the process of how organizations handle or they address the risks that they face. A common reference when we think about risk would be a data breach where hackers break into our network and they steal data, but there's a lot of different potential risks that exist. So knowing that we need to address risk, what are some of the ways that we can do that? Security policies are at the heart of managing risk because they're documents that define how an organization is going to protect their IT infrastructure. Some of the common ones that you'll need to know about include acceptable use policies, network access policies, mobile deployment models, onboarding and offboarding policies, and externally required policies. Keep in mind that there's other policies that might exist, but these are the common ones that we're going to cover. Have you ever had a job where you needed to access your company's computers? You probably had to sign an acceptable use policy, among other things, before you could actually get access. Acceptable use policies, or AUPs, are policies that define what's considered acceptable and what's not considered acceptable to do with organization-owned computing devices. Common things that you'll find in an acceptable use policy include ownership definition, where it clearly states the organization owns the equipment and any information stored on the system and network. Network access agreements, saying that you'll only access what you're permitted to access. Consent to monitoring or privacy agreements notify you that your activity is going to be monitored by the organization on their systems and networks, and your activity is not considered private. And illegal use statements, saying that you agree to not break the law with your activity on company systems and networks. This can include hacking or other activities. Network access policies state who has access to the network, what they're able to access, and how they can access it. These kinds of policies are based on the idea of least privilege, which means that users aren't given blanket access to everything, and their access should be restricted to what they need to do for their job and nothing more. The access is usually broken down with a role-based approach by specific job or department, and the rights are assigned that way instead of assigning them to individual user accounts. This makes the overall management of things more secure and easy to administer. Common network access policies include password policies that define how complex a password has to be and how often password can be reused, data loss prevention policies, or DLP policies that talk about how data is managed so that it doesn't get leaked outside the organization. This can talk about using redundant hardware, backups, access levels to data, or even how equipment is sanitized when it's no longer required. And remote access policies define how employees can remotely access the corporate network and even from where employees can access the network. A VPN policy is a more specific example of a remote access policy. Today, it'd be weird to not see any mobile devices, whether that's laptops, tablets, smartphones, or whatever other type of mobile device that exists. In a lot of organizations, users have options when it comes to using company-owned devices or their personal devices. So let's talk about some of the models that exist. BYOD, bring your own device. This is a type of deployment model where employees can use their own personal devices at work. Of course, a huge benefit of this is that employees purchase a device that they're comfortable with using. BYOD also has its challenges. For example, an employee could have a device that's already been compromised. Employees also expect more privacy on a personal device compared to a company-owned device. BYOD policies are extremely important if you're going to allow employees to use their own devices. Some of the things that these policies include eligible devices that can be used, security requirements to enroll, if the organization will help purchase devices, what to do if the device is lost or stolen, or shows signs of malware, and any legal risk that an employee is accepting along with the rights that they might be giving up. COBO, or corporate owned business only, is another deployment model where the company owns all the mobile devices and issues them out to employees. This is pretty common in a lot of companies that are going to provide you with what you need and maintain it. COPE, or corporate owned personally enabled, is similar to COBO, where organizations issue mobile devices, except employees are also provided with a whitelist of approved applications that they can install. CYOD, choose your own device, is the last mobile deployment model, and this is where employees are provided options of mobile devices that they can choose from. The company controls and owns the device, but employees can install their own apps on the mobile devices. When a new employee joins an organization, they have to go through various onboarding processes or steps to make sure that they get everything that they'll need in order to do their job. This means badges, accounts, keys, and anything else that you can think of. Offboarding is basically the complete opposite, where employees return everything they got issued and then their accounts or their access is disabled. Mobile devices, like we just talked about, are also part of the onboarding and offboarding process. All the mobile systems are onboarded and offboarded within a mobile device management or MDM system. The enrollment process might be as simple as visiting a URL, or it might require hands-on steps where you physically plug in the device to register it. By enrolling the device into the MDM system, it can get the appropriate security policies and settings that are required. When the device needs to be offboarded from the MDM system, all company data and applications are wiped clean and the device is deactivated in the MDM system. Like a lot of things, government laws and regulations impose certain policies on organizations. There are laws like HIPAA or the Health Insurance Portability and Accountability Act of 1996 that requires special ways of handling and storing healthcare data. There are also import and export laws for countries. This is important because if you have certain types of data on your system or you can access it, simply traveling out of the country could open up a can of legal worms. So it's important that you comply with any relevant laws and regulations. What if a company doesn't adhere or follow their policies? Well, what's the point of even having policies then? Policies are meant to be consistent in their application, current, meaning that they're up to date, and enforceable, meaning that the penalties for violation are in accordance with the law. Additionally, the policies must be accessible by employees. If nobody can access or review the policies, then by nature, they aren't enforceable because nobody knows them. The overall IT infrastructure and technologies that we implement in our organizations are ever changing, which means that you'll replace equipment and adopt new technologies over the years. Change management is the process where we can create change in an organized, controlled, and safe way. There are two ways that change gets initiated. The strategic level, where changes are initiated by management and are significant in scope. And then we have the infrastructure level changes, which are initiated by a department making a request. This is probably the most relevant type of change that you're going to run across. Now we're going to talk about the process to actually make a change in an organization and the steps that are involved. Step 1, initiate change. Change starts with a change request, which might come in the form of a document, email, or a ticket in your ticketing system. Documentation is extremely important for changes, so you'll want to capture type of change, such as software, hardware, or many other types, configuration procedures, including what's going to happen and who's going to be involved, the rollback process in case something goes wrong. What do we need to do to roll back configurations to that previous state? Potential impact identifies how this is going to impact the organization. Does it save money? Does it save time? Or whatever the impact is. And the notification includes the steps that notify the organization and how it's going to be done. Step 2, notify the CM team. Companies have change management teams or change advisory boards that review proposed changes and provide a formal approval. Basically, these teams are making sure that any involved departments are considered with regards to the impact. That's why it's not uncommon to have members from across the organization. These teams meet at regular intervals depending on how frequently changes happen in your organization. Step 3, making the change. Now that the change is approved by the board, you've got to go purchase or acquire the necessary software, equipment, or whatever you need. Configuration teams need to be trained or informed of what needs to be changed. Change committees also need to provide a maintenance window to give enough time for changes to take place and to be tested. If there's any downtime required, that'll also have to be addressed with the maintenance window. You must make sure that any people that are going to be affected receive a notification of that maintenance window and downtime. We don't want any of them to be surprised. Step 4, documenting changes. Updating documentation should be an ongoing process that never ends. With that being said, once we have changes implemented, it's likely that some of our documentation needs to be updated. Things that might need to be updated in your documentation include network configurations, server settings, routing settings, and so on. If you've added any network gear, that has to be documented. Any physical location changes, like hardware moving from one location to a different part of the building. Standard operating procedures, or SOPs, are formal documents that give detailed procedure of how to accomplish some task, so these should be reviewed and modified as needed as well. Installing patches and updates is probably the most frequent change that you'll see on any network. Vendors like Microsoft frequently release patches for software and firmware that might even include a critical security fix. Common types of updates include operating system updates, which might be manually installed, but in large organizations is more of an automated process that slowly rolls out to systems. Microsoft is known for Patch Tuesday, where they deploy new patches on the second Tuesday of the month. Device drivers to fix issues or incorporate new features, software updates to fix any kind of bugs, and firmware updates to networking gear and other devices on your network. There's a few things to keep in mind with regards to patching. First of all, do your research on the patches or updates. Make sure that people aren't having issues with them and identify any time that new patches are released that apply to your network. The next thing is test your patches or updates on test systems to make sure they're not going to break anything. Configuration backups are an absolute must when performing updates. It wouldn't be the first time that an update has completely crashed the system, and it won't be the last. Roll patches out in waves so that you can identify issues quickly at a smaller scale than network-wide. Now that your policies are in place, let's talk about training employees and how that fits in. Plain and simple, you must give employees training in your organization. Training helps to reduce risk to the organization and enables your employees to be a part of the security solution instead of the problem. Training topics can include security policies being agreed upon and signed by users to acknowledge them, passwords so that users create complex passwords and they don't write them down, physical workplace security to include staying alert around visitors, notifying security of doors propped open, confidential documents in the open, and other items that generally result in security issues. Social engineering so that employees are not easily tricked by attackers, and malware, specifically how to avoid it and what to do if they think their computer's been infected. Whether you're dealing with a third party outside the organization or a department within your organization, there are several common agreements that you need to be aware of. First is a service level agreement, or an SLA, which is between a customer and a service provider that documents the scope, the quality, and terms of a service to be provided. For example, with an internet service provider, you'll see how much bandwidth you're guaranteed and the uptime of services that you're guaranteed. Memorandum of Understanding, or MOU, is a document of agreement or a legal contract when it makes sense. This might be between businesses that deal with each other frequently, but you also might see these used internally. Multi-source agreements, or MSAs, detail the interpolarity of components. For example, a manufacturer might have an agreement that their components will work with vendors X, Y, and Z. Statements of work, SOWs, or SOWs. This is a legal contract between a vendor and a customer that defines the services and products to be delivered and the timeframes to supply them. And non-disclosure agreements, or NDAs, are legal documents that prohibit the signer from disclosing company secrets that they learned at their job. These are used internally with employees and also with external companies who might need to know more specific details when working with your company. Although we say most of the discussion about security assessments and preparing for them for the Security Plus exam, there are some things that you need to be aware of for the Network Plus. Specifically, we're going to talk about some important assessments, business continuity and contingency planning, and incident response procedures. At the core of what cybersecurity teams do is identify and assess risk with the help of risk assessments. Security risk assessments categorize fundamental aspects of risk to include threat assessments, vulnerability assessments, penetration testing, and posture assessment. Each of these aspects or categories tries to identify bad things that can happen to anything of value in the organization, which we refer to as an asset. A threat is anything that has the potential or capability of an event or bad actor to cause damage to company assets. Threats are frequently thought of as people, but that's not necessarily true. Threat actors, though, are a person, organization, or a nation state that has the capability or intent to harm, steal, copy, or otherwise diminish an asset. Threat assessments are the analysis of any threats or threat actors that exist, and then they're prioritized or ranked based on both their likelihood of happening, so is it likely, or how possible is it, and then how much pain or impact would they cause. Simply, how likely is the threat and how much damage can they cause? You might have heard of a vulnerability before, but it's basically any weakness or flaw that exists, whether that's non-technical like a policy, process, or physical aspect, or it can be technical like a bug in code or missing patches. Ideally, the more that we can link dollar values or intrinsic value to the company, the easier the whole process is going to be to prioritize things. When it comes to technical vulnerabilities, we can use a vulnerability scanner which automates checks and it generates a vulnerability assessment report that we can then act on. Common vulnerability scanning tools include Nmap, which is short for Network Mapper, and is a command line tool used for scanning ports, network inventory, and relatively simple vulnerability scanning. There's also a graphical user interface version of Nmap called ZenMap. OpenVOS, which is a free open source scanning tool that has a web interface and is actually a forked version of our next tool. The next tool is Nessus from Tenable, which is a very popular commercial tool, but they also have a free home license that you can use, and it also has a web interface. All these tools are part of a vulnerability management program that focuses on identifying, tracking, and mitigating vulnerabilities throughout an organization. One of the limitations with vulnerability assessments is that they don't attempt to exploit any found vulnerabilities, which can result in either false positives or findings that aren't of actual concern. Penetration testing, or pen testing, takes vulnerability findings, like from a vulnerability assessment, and uses ethical hackers, also called white hat hackers, that we hire to attempt to exploit them. This is much more like a real-world scenario, except the hackers are either internal to our company, they work for an authorized third party, or they're approved through a bug bounty program, which is basically a crowdsourced penetration test. Of course, the objective isn't to destroy the network or to sell off any data that can be accessed. However, these findings are extremely valuable to secure our organization. These pen tests are carefully documented with what's allowed and the timeframes for testing. Penetration tests frequently include Kali Linux, which is a Linux distribution full of security tools. One of the most common tools in Kali is called Metasploit. As you start getting more comfortable in this industry, it's a good idea to learn about some of these tools because they can be useful even if you don't want to work in a dedicated security role. When we talk about risk posture, we're referring to the overall risk for an organization. This includes applicable laws and regulations and threats that exist, whether they're man-made or natural disasters. In order to determine the risk posture, we have to perform a posture assessment to identify all the risks or threats that the organization faces. The assessment needs to include the costs associated with the risk, which means both the monetary costs and the time costs that the organization might incur. Business risk assessments are another type of assessment that you need to know about, and they're focused on operations in the organization. Important business risk assessments include process assessments, looking specifically at the risks associated with various processes in the organization to achieve a specific result, outcome, product, or service. This might include the actual production process of a product, but it can also include the processes to procure or acquire certain materials needed to make the product. These processes also contain sub-processes like a process to research best ways to make the product or selling the product. All these processes have to be prioritized. Vendor assessments examine third-party security controls, procurement, labor policies, and other aspects to identify risks associated to these outside organizations. The big reason for this is because most companies don't produce everything that they need or use in their own business because of cost, expertise, or many other reasons. Ultimately, we're dealing with technology in this career field, and bad things eventually happen despite our best efforts. Incidents are those events that negatively affect an organization, that hurts or compromises its people, systems, or ability to function as an entity. Contingency plans document how to limit damage and recover quickly. That way, if an incident occurs, we can respond effectively and efficiently. There are 3 groups related to contingency planning that we're going to go into further. Incident response, which focuses on stopping, containing, and remediating incidents. Disaster recovery kicks in if the incident can't be contained or if significant damage or danger is happening with the immediate infrastructure. And then business continuity is used when the disaster forces us to take actions off-site from the primary infrastructure. The incident response process relies heavily on the incident response team. For example, you'll have first responders who are pre-assigned and have policies for what to do. These members might have the role of qualifying what is considered an incident and if they should escalate it. A lot of incidents are handled at this level, but you should have detailed incident response policies and a detailed incident response plan to guide the actions of the team in potential scenarios. If the incident can't be stopped, contained, and remediated, then the disaster recovery process has to kick in. Disaster recovery deals directly with recovering your primary infrastructure from a disaster. Disasters include anything that disables or destroys substantial amounts of infrastructure and could be natural disasters like hurricanes or man-made. Disaster recovery plans, or DRPs, are at the core of this process, and it outlines how to deal with disasters. Usually there's a specific disaster recovery team that, when called on, is going to focus directly on getting the primary infrastructure back to normal. Data and system backups are very closely tied to disaster recovery efforts. These backups might be configurations or actual system and data backups. It's crucial that you have backup plans in place. These plans identify a few key metrics that you need to know about. First one's recovery point objective, or RPO, which states how much data the organization can tolerate to lose if it needs to restore from a backup. This drives how often backups are performed and which type of backups are completed. The next one is recovery time objective, or RTO, which states how long the organization can tolerate an outage before full functionality has to be restored. Basically, the amount of time needed to return to normal. Let's talk about a few more key metrics that go into disaster recovery, but might not necessarily be in the plan. The first one's mean time between failures, or MTBF, which applies to hardware and is the manufacturer's best guess based on data of how long the hardware can be used before a failure might occur. This assumes multiple failures are possible with the hardware, so it might need to be repaired at that point. The next one's mean time to failure, or MTTF, which indicates the length of time that a device is expected to last in operation. This indicates when the device will have to be replaced, not repaired. And then mean time to repair, or MTTR, is the amount of time to fix the system after it fails. This means repairing or replacing components and restoring the system to a fully functional state. Remember, disaster recovery is concerned with the primary location. If you need an off-site location, then we need to talk about business continuity. When things go wrong at our primary site, it's not uncommon to need remote sites to keep the business going. Business continuity focuses on the planning and processes necessary to do this. Business continuity planning, or BCP, details the risks to critical systems, the cost to replace or repair systems, and how to do these replacements or repairs in a timely fashion. Since business continuity deals with remote sites, there's a few terms that you need to know about. A cold site is another location with desks, chairs, furniture, basically everything but computers, which means that you have to move them here. This is by far the least expensive option to maintain. Warm sites are like cold sites, except they have computers loaded with software and functioning servers. You won't have the data yet at warm sites, and you may or may not have an active internet connection. To spin up a warm site, you're probably looking at a day or two to restore backups and get up and running. Hot sites are like warm sites, except you'll have recent data backups. These are frequently a duplicate of the primary site and should only take a few hours to bring online. Cloud sites are basically everything stored in the cloud. This actually makes the restoration process fast and easy because you only need an internet connection to basically be back up and running. Keep in mind that with a lot of these plans, you'll have people in the organization who are assigned specific roles with regards to recovery or continuity. Also need succession planning, which identifies alternates or backups to those people if they're temporarily unavailable for whatever reason. Something really important with regards to security and incident response that we don't touch much in the Network Plus is forensics. You need to at least be aware of what it is, since the first responder to an incident is crucial. Computer forensics, sometimes referred to as digital forensics, is the science of gathering, examining, analyzing, preserving, and presenting evidence stored on a computer or any form of digital media that's presentable in the court of law. As a Network Plus professional, your involvement as a first responder might be to collect information and present the authorities with that information. Since we deal a lot with memory and forensics, you need to know the difference between non-volatile memory, like your hard drive, and volatile memory, like RAM. In forensics, all this information has to be protected so that it can be analyzed later and so that it won't be tampered with intentionally or unintentionally. There are three major tasks that you need to be aware of: securing the area, document the scene, and collect evidence. When an incident happens, as a first responder, your job is going to be to secure the area. This might mean preventing people from entering the area or preventing access to a system. As a first responder, you need to know when to escalate the incident. Now you need to document the scene. Preserve the state of systems, meaning don't shut them down, and look for anything that might need to be inspected with forensics. Taking pictures of the scene like a crime scene investigator is always a good idea, because if anything gets moved, the scene's been altered. Take notes of any electronic devices, external hard drives, USB drives, cameras, phones, or anything else that you see. Now that the area has been secured and we've documented everything, it's time to start evidence or data collection. Keeping track of chain of custody for items is extremely important. This is basically a paper trail of who has access to the evidence at any given time, what that person did with the evidence, where the evidence went, and this starts as soon as you collect the evidence. Forensics examiners will take hashes of electronic systems or hard drives because any alteration of that system compromises the evidence. This process will generate a forensics report where items are tracked, like the examiner's name and title, examiner's qualifications, objective for the forensics, any case or incident numbers, the tools used, where the examination took place, any files that were found, log file outputs, screenshots, and hashes of systems or hard drives. Sometimes these reports will have a legal hold on them if there's a pending legal issue or if the authorities need to access the reports. Additionally, your forensics examiners might have to serve as an expert witness in court.